What does it really take to deliver innovative applications and run more efficient teams? Well, it's more than just Kubernetes. Success depends on whether you have the skills to not only manage Kubernetes itself, but also the ecosystem of tools and services needed for a complete application platform. I'm Michael McNeil.
And I'm Andy Repton. We're black belts at Red Hat, and today we wanted to walk you through some of the benefits of Red Hat OpenShift Service on AWS, or ROSA for short, a fully managed, comprehensive application platform. ROSA enables organizations to concentrate on building, deploying, and scaling their applications, rather than being burdened with ongoing platform management and maintenance. So Michael, where should we start?
Let's go to the whiteboard.
Great.
So what is ROSA? When we talk about ROSA, ultimately, it is a fully managed application platform. It's turnkey. It's designed to be able to take your applications from zero to hero in a very fast process. And it does that by offering a multitude of tools that customers can actually use to take advantage of the different application platform benefits. As a part of that, the ROSA service offering is a fully managed service. It's jointly managed, supported, and engineered by AWS and Red Hat together. And that is wonderful because ultimately for customers, it provides them a huge benefit to being able to rapidly start using this. Simply going into their AWS console, clicking the Get Started button, and they can start deploying a cluster and building their applications. Ultimately, all of this is done and managed together by a set of SREs that are responsible for keeping your cluster running, so customers can focus more on what matters to them, driving value for their business. So, Andy, what does this actually look like in practice?
Great, thanks, Michael. Yeah, so the basis of any OpenShift cluster at the end of the day requires worker nodes, as we call them. And these will be created inside your VPC. And I'm just going to draw out 3 of them here. These worker nodes essentially are going to be the very basis of any applications that you then want to run on top of your platform moving forwards. These live inside your VPC and are connected then to a abstracted hosted control plane. How does that work, though?
Yeah, absolutely. So all of these worker nodes live inside of your VPC, and the actual control plane lives in an abstracted mechanism that is connected using a VPC endpoint directly to your VPC. And so what that means is that traffic to that dedicated control plane is available to you, but you don't have to pay for the compute resources or the storage resources or anything along those lines. It provides a significant amount of benefit to end users to be able to actually rapidly spin up clusters, be able to manage them in a way that actually is quick and easy, but also supports their individual needs. And this hosted control plane is entirely abstracted away. Customers don't ever have to look at it. They don't have to worry about it. Ultimately, all they're caring about is what they're actually running on top of the platform.
Great. And interestingly, hosted control planes is the newest iteration of architecture for ROSA. Previous iterations, which we would call ROSA Classic, actually used to have the control plane here inside the VPC alongside your worker nodes, which was quite a large overhead for customers who really just wanted to get focused on application modernization or innovation projects.
Exactly. One of the challenges that customers told us about consistently was, well, we don't want to spend the money to actually have to run these inside of our account. We want to really worry about the things that we are paying for only, and everything else should be abstracted away. Ultimately, this is an opinionated and managed service offering. Why do we need to have that inside of our account? Well, as we've gone and worked on evolving the service, like you said, we've done a lot of work to make sure that that is as seamless as possible for customers. So tell me a little bit about how I actually start deploying applications into this environment with this hosted control plane.
Yeah, great. So now that we have the cluster, the next question is, what do we do with it? Well, the nice thing about ROSA is that the possibilities are almost endless. Let's say that within one cluster, you had a team that wanted to investigate OpenShift AI, for example. So they want to run an AI workload with a GPU attached to it. And another application team might wanted to deploy a microservice architecture with lots of small containers, all running some sort of internal development platform. And a third team, maybe your platform team, has to move some legacy VMs into the cloud. Well, they can actually install OpenShift Vert on top of our ROSA cluster and add in a worker node that potentially is a bare metal instance. all of this is possible now within ROSA, and it allows your various teams to take advantage of the multi-tenant capabilities of OpenShift, all while having the underlying infrastructure and the platform itself managed by Red Hat and AWS.
So just to make sure I understand, so you're saying that all of this can run inside the entire, like just one cluster. There's no need for additional clusters at that point. I can just run a bunch of different things side by side.
Exactly. And leading on from that, imagine if we wanted to do some very specific upgrade targeting. Right? So maybe the OpenShift AI team want to test out an upgrade of OpenShift, but the OpenShift virtualization team is not yet ready. Would that work with ROSA?
Yeah, absolutely. So when we talk about hosted control plane upgrades, one of the cool things is that we can segment all of these upgrades separately. So let's say for right now we're running our nice HCP here. We're running 4.19.0, and we want to upgrade to 4.19.2, right? So we can easily upgrade this, right? 4.19.2. And these workloads over here can be running 4.19.0, 4.19.0. And then the AI team is like, I want to upgrade to get a fix of some sort, right? Well, the great news is we can individually upgrade this specific component to 4.19.2. So these nodes will get replaced with new 4.19.2 nodes, while these nodes that have a dependency on a lower version can continue to run. And one of the even more neat features about this, in my opinion, is that instead of just being focused on this Z-Stream version, that last version, instead we can actually run up to N-2 versions. So these could even be running OpenShift 4.17, for example. So workloads that are heavily dependent on a specific version have the ability to run even further, even older releases to be able to support those needs.
That's brilliant. And as addition, the other thing is that all of the upgrades is part of the managed service, right? So,
that's right.
Yeah.
Yeah. So when our SREs are actually managing and monitoring the cluster, they're also responsible for making sure that upgrades happen and they occur when you schedule them to happen, that they occur in the way that you've scheduled them to the specific version, but also they go and address issues as they're detected without you having to have any sort of intervention. They do it automatically out of the box. And our teams are constantly monitoring these environments to make sure they're up and running and available so that you can rapidly deploy your applications.
Great stuff. Should we head back?
Yeah.
Great.
So that was a brief overview of the Red Hat OpenShift service on AWS and the benefits of the hosted control plane architecture. That includes offloading control plane management, increased reliability, and additional cost savings. To learn more about ROSA, check out the links.